session 1 of day 1 of PyCon Indonesia 2020. I will be, my name is Siki Dewanto, and I will be moderator for this session. So for this session, we will have a demo from ScoutAPM, one of our sponsor, gold sponsor, and a bit about ScoutAPM. It is a cloud service about application performance monitoring. It is a very cheap alternative for APM solution. So without further ado, let's let us see the presentation from Scout.
Hello, today we're taking a look at some features of Scout application performance monitoring. Today we're looking at a Ruby on Rails application instrumented by our Ruby agent, though the features found here are also applicable to applications written in Django or Flask, instrumented by our Python agent as well. When you first start instrumenting your application with Scout, you'll notice that the application metrics starts flowing in on this overview page. And you'll start seeing these metrics on this chart here. The metrics are average response time, the 95th percentile response time, your throughput, errors, memory, and AppDex value. Currently, we're on a 3 days time frame. You can go all the way out to 7 days. 7 days is great for looking at your weekly periodicity or seasonality between days. And we can see that during our weekdays, we do have higher throughput, and during the weekends, it's a bit lower. Scout integrates with GitHub. When you integrate with GitHub, you get to see exactly what branch or what revision is running on your application currently, when it was deployed, the authors, and the number of line difference commits here. You'll also get to see with deploy tracking the exact branch and when it was deployed. When these rocket ships show up, that's when you did a deploy. It's very useful for seeing code behavior both previous and after a code deployment. Let's go back to a 3-day value. So as you hover on this overview chart, you can see that as you hover, it shows the different layers of what was happening during web requests for this particular time. During this clear spike here, we can see if we go down and look, it was actually time spent on our Git proxy layer, in addition to active record, which is similar to SQL Alchemy, and some time series database time spent here as well. A very handy thing to do in Scout when you see a spike like this is to click and drag to hover over part of your chart. When you do that, you notice that these times here actually changed, just to show the reflected time just for the selected part of the chart. When we highlighted and selected part of the chart, we also got this drop-down menu, which can be sorted by largest memory increase or by max response time. Since we're looking at a response time spike, we want to look at the max response time sorting. And at a glance, we can see that it looks like it's the deploys controller index that matches this pattern. And if we click directly into that, it takes us to the deploys controller index endpoint, where we can see that matching response time pattern shows up as well. And it was our Git proxy layer that also caused that response time. We'll dig into this a little bit further in the demo as well. If we go back to the overview page, we see down below the metrics chart that we have these insights that Scout is really good at pulling out. First one is N+1 insights. These are queries where you're doing multiple queries that could be optimized to do less queries and result in shorter query response times. We show you the number of queries and how much potential savings you could have by optimizing these queries from N+1s to something like eager loads or includes on models or columns on your database. Some of these worst offenders for us look to be admin page N+1s. but we can also see that there are a few that are on other endpoints that can be optimized as well. These are super helpful for easy fixes to your code. It's easy to sneak these in when you're developing just by using your ORM. ORMs are super handy to use, but they do allow you to sneak in these unfortunate slow results in N+1 queries that only show up typically during production. So if we click into one of these, we can see that indeed we've tagged all these N+1s in a tag that says N+1. You can see that we're fetching 20 of these, and then we're doing other operations on those 20 calls, and it ends up with a large response time. We can optimize these by doing eager loads or includes in Ruby on Rails, and you can do similar things in SQL Alchemy to cut down on your query time. You can see that we capture the exact SQL that was executed, as well as a backtrace of when this actually occurred. You can see the exact line of code for this particular request and who committed it. If you highlight it and click on the view in GitHub, you can actually go to the exact line of code that was captured or executed in this backtrace. So tackling these N+1s is a super simple way to cut down on your response time for your application. Another insight that we surface is slow query insights. These are queries that are consistently slow for certain endpoints. You can see that of these slow queries, they consist of at least 23% or so, up to almost 88% of each of these controller actions. And again, if you click on one, it'll take you directly to the endpoint where it happened, and it'll open the breakdown section of the endpoint of where it occurred in the request of this controller action. You can see it was 88% of the time consumed, with an average response time in just this one layer of 1,000 milliseconds. And if you expand it, you get to see again the exact SQL. And if you look at these buttons down here, you can see the exact detailed trace request that was captured that includes this exact SQL query. Click into that. It'll take you into the detailed trace that was captured, point you directly at that layer where you can again see that SQL, and again go straight to the line of code. Right here. Tackling these slow queries can save you, again, lots of time in your response time. These start creeping up sometimes when they're first introduced. It takes some time for them to start actually being slow, depending on how much data is in these actual database tables. So these are a good thing to kind of keep an eye on for slow burn type performance issues for your queries. Ruby and Python have garbage collected, interpreted code. So the actual Python or Ruby VMs are responsible for allocating and deallocating and giving back memory to the operating system. Typically Ruby and somewhat Python are very slow in giving memory back. So any memory that's actually allocated to your application tends to come back very slowly to your operating system. So in the case of memory bloat, where you have something that causes a very large increase in memory usage, that will increase your overall watermark for your application. And that typically doesn't go back down until you do deploy. So if you keep an eye on your high watermark of your application and you tackle these endpoints where maybe you can optimize for doing streamed processing or some batch processing within lower batches, you can prevent allocations all at once, which would increase your high watermark memory usage. So we can pull this out automatically and point you directly to what's happening in a particular endpoint that's allocating a lot of memory. Here we can see the number of allocations and the layer which was responsible for it. In this case, it's a view partial that renders a lot of data. Scout also integrates with error services like Sentry, Rollbar, Honeybadger, and Bugsnag. So depending on what time frame you're looking at, you'll also be able to see the number of errors that were captured during this time frame. Super helpful to see errors and performance data side by side. I'm going to highlight again on this overview chart. And we'll notice that this highlight actually stays with us for certain page reloads as well. We'll go to the web endpoints page, listing all of our web endpoints. These can be sorted by time consumed, which is the response time by the amount of throughput of every single, compared to every other single request that happened in your application. This particular endpoint was responsible for 80% of the time consumed of all the web requests during this time. You can also sort it by response time, throughput, allocations, and error rate. You can see that that highlight actually sticks with us as we navigate a few of these pages. This helps us keep our context into what time frame, what time period we're actually investigating for something like throughput or a response time spike. When we click into the endpoint, it'll take us again to that endpoint page where we again see this chart that has the same metrics on it. And below that chart, we see the breakdown table. This is what happened during the requests for this particular endpoint action, and how much time, average total time, and how many times that layer was triggered. So for our Git proxy layer, that actually consumed 95% of the time in this endpoint. So we can tell that if we spent time optimizing this Git proxy layer, we would actually be able to reduce our time consumed in our response time for our application by quite a bit versus focusing on any of the other layers at this point. Some of these layers in the breakdown table are expandable. Things like SQL calls are expandable. We saw previously that if you expand these, you get to see the SQL that was captured. And again, the detailed traces that were captured with this exact SQL contained in that request. If you click on the Traces tab, this is the list of the detailed traces for this endpoint that were captured during this time. Scout actually captures timing metrics of every single request that goes through your application. We do not sample timing metrics. What we do collect, in addition to all of those timing metrics per minute, are a handful of interesting detailed traces. These are traces that contain a lot more detail and break down specifically how long each layer or span took during that request. And we can order by the slowest response time to see that, we have some really bad ones in some cases here. We can also order by most allocations, largest memory increased, or just most recent. Click on a detailed trace. You get to see the overall breakdown of each layer here, the overall response time, and a detailed breakdown, kind of waterfall view of all of the layers in the detailed trace. By default, we show the condensed view. The condensed view tries to point out which layers were actually taking the longest during the time during this request. And if you unclick the condensed view, you get to see in detail what happened as your request was being handled. So you can see there's some SQL calls. Down here, we hit an n+1, and then we called a render, which then called a few more SQL calls. And then we rendered a lot of templates to actually display the web page. So you can get a very, very detailed breakdown of what happened within your request through these detailed traces. This is the time breakdown. You can also see the memory allocation breakdown. This is where the memory allocations happen. Both in Ruby and in Python, we can track actual allocation counts through each request, in addition to actual memory used. Allocations, if you have more allocations, that just means the garbage collector is going to end up doing more work, which typically means a slower response time for your requests and for your application. So doing less work means less work or doing less allocations means less work for the garbage collector, which means your app is typically a little bit faster. Context is detailed business information that you can attach to detailed traces, things like org ID or user ID, so that you can correlate that user in your own database as you're looking at performance problems. Very handy. Here we can see background jobs as well. We'll continue to highlight that certain time that we did on the overview chart, and we can see that it also follows us here as well. The background jobs index page is very similar to the web requests index page. You can also see the queue time, or the queue name, the execution time, throughput. Latency is the time from when the job was enqueued to the time when it actually started being executed by a background job worker. Again, with the allocations and your error rate. Database tab gives you a view of your application's interaction with your database throughout a certain time frame. Again, that highlights here. We're going to take that off for a minute. So we get to see a top 4 of SQL queries, and then everything else grouped under other queries here. Again, we have the deploy markers shown on this, so we can see before and after kind of changes of code deploys. And we can see that node find, node count, SQL commit, and flag trace create are our top 4 queries against our database. And if we go down to the table below, we can see by sorting by time consumed, this request find from this actual background job is consuming 30% of our time, query time against the database. So by far and large, the amount of queries that we're doing to our database and the time consumed is actually used by this particular background job, and specifically by the request find operation within this background job. We can expand that to see the exact SQL queries and also the detailed traces where this occurred. With the highlight again on the page, we can see, let's move to a different time frame. So if we look and highlight here with just our dragging on the chart, we notice that the table down below actually dims out certain queries and highlights other queries. The queries that are highlighted are actually the queries that changed the most during this time that was selected on the chart, on the overview chart. So we can see here that it was a node find based on the color, and then as we selected it, it actually automatically highlighted that node find to tell us exactly where that came from, which controller action that came from. It, during this time, increased from number 9 to number 3. It moved up 6 places. The throughput went up 345%, and the 95th percentile actually dropped a little bit. We can use the expansion to see which detailed traces were collected during this time frame. And again, we can click through to see exactly in this detailed trace where it happened. It's another case of an n+1. This can be optimized pretty easily by doing eager loads or includes. And we can also see exactly where the line of code is. So the database tab is very, very, very helpful for seeing what your application is doing against your database during a certain time, and also for finding offensive queries that are either slow, spikes in database time, things like that. Take the highlight off. Moving to the traces tab, we can see that we get charts here that show us response time and endpoint, also with memory allocations, and then below that, any custom context that was contained in these traces captured. So we're actually looking at the last 3 hours. We're pulling the slowest detailed traces of our web endpoints. And again, we can highlight on the chart. And as we highlight, we can see the dynamic change in other charts to see what was included during this time. So we want to look at super, super slow requests, what was actually included. Our admin controller needs a lot of love. We slide down, we can start saying, okay, it's not just admin anymore, but it's also apps controller. And then if we slide down again, we can see a bit more of what was starting to get slower, very slow. And then as we slide down even more, we can see that our faster ones were the majority of our endpoints and what was included there. If we go down and we wanted to see, we just want to see what was slow by a certain IP, just click that. It'll show us what endpoints were hit by this particular IP and what the response times again were, and we can filter further saying, let's take a look at just the ones that were caused by this endpoint, and down below we'll see the detailed traces where we can click directly into that, and it'll take us right to that detailed trace. So the Trace Explorer is super handy to get a handle on outliers of certain amounts of time, break it down and pivot by custom context and endpoint names and other information collected. You can set up alerting to alert on certain thresholds of application metrics, things like throughput, response time average, 95th percentile, errors, and apdex as well. We currently support webhooks and email for alerting. You can set overall thresholds for your overall all web requests or just certain endpoints as well. And that's it for the walkthrough of some of ScoutAPM's features. Hope you enjoyed it.
Okay, thanks to ScoutAPM for the presentation. So unfortunately, Scout is not joining us in our session today because of time zone difference. So if you have any question, please ask it using the Google form link that's available in the chat session. Okay. Thank you very much. This is the end of the first session in room 2. Hope you enjoy the session. See you in another session. Bye.